Hello, welcome to Tinkerdoodle DIY. In this video, I'm going to show you how to make a sensor data logger that runs on 2 AA batteries and can last for more than a year. Recently, I decided to make a sensor data logger to log the soil moisture as well as humidity and temperature for my garden bed. Since the garden bed is outside of the house, the only option to power it would be to use batteries. I first tried to use this popular load MCU board, but unfortunately it consumes too much power. Even when I put the ESP8266 in deep sleep mode, it still consumes as much as 10 milliamps. So for 2 AA batteries, that means it can only last for a few weeks, a couple weeks. So I end up go with this ESP12F chip. That is much more power efficient, and in deep sleep mode, it consumes as less as 20 microamps, which is more than enough to power the whole device for more than a year. The ESP12F is not very breadboard friendly, so I end up use a 3D printed adapter to adapt it to a breadboard, and I use the paper clip to hook up the wires. You also need a ESP8266 programmer to connect the ESP12F to your USB port. This can be slapped in right here, and you can clip the USB port in the same way as you connect the load MCU board. So let's connect the ESP12F to the programmer and program it first. Connect it to the USB port. And open the browser, go to Tinkerdoodle. Here I already have the page. So let's go to the shared and Tinkerdoodle folder. Open the low power sensor data logger notebook. We'll go through the parts list later, as well as the schematic later. Let's run the flash command to flash the MicroPython firmware. The whole flash process may take a minute. Okay, now it's done. Let's also take this opportunity to put the code, write the code down to the ESP12F. Basically what this code does is it runs hourly, and each time it connects to the network and read the soil moisture sensor as well as the temperature humidity sensor, and send the data to a Google spreadsheet. And once it's done the work, it put itself into deep sleep mode to be woken up 1 hour later. So on the server side, it is handled by an app script that runs at script.google.com. The code is pretty simple. Just copy this code and go to script.google.com, create a new project, and put the code there and deploy. Once you deploy, you will see URL, just write down the ID portion to be used as a connector ID, which you use to replace here. Also, be sure to write down your Wi-Fi SSID and password here before you run this download this code. Well, let's just download this code. Okay, we're done. Now let's go through the parts. So the main one is ESP12F, and we already showed you the programmer. And the DHT11 temperature humidity sensor, and the soil moisture sensor. We also need a battery box. Since the ESP12F can take about 3 volts, so it is fine to run ESP12F directly from the battery box. We also use a mini breadboard to hook up the wires, as well as this breadboard adapter for ESP12F. I also prefer to use this rigid wire so that the wiring looks less messy. Okay, once you're done with everything, the assembled parts looks like this. And you're ready. When you're ready, once you're fully assembled, we can do a test by turning on this button. And let's go to our spreadsheet. You can see I already have some data here. This was from an earlier version of this device, which doesn't have the moisture sensor. So I only have temperature and humidity. So you can clearly see the data pattern of the temperature and humidity. Let's scroll down to the end. Yeah, now we can see it starts and uploads a new entry to the spreadsheet. So that is cool, right? It's even cooler that this whole thing can run on battery for more than a year. Okay, thanks for watching.